Good afternoon, everyone. It's Gary Richardson here from 6.6. Welcome to our BrightTALK. This afternoon, or wherever you are in the world, it's a beautiful sunny day here in London, and we're going to be taking you through a relatively quick talk around what I've entitled Busting Data Lake Myths and Dragons. I was going to go with legends, but I don't think we're at this point yet within data lakes that we actually have legends yet, but we'll run through a couple of myths, and we're not going to get too technical. What we're going to focus on is a couple of items that tend to trip up data lakes, and hopefully at the end of this talk you'll have some good anecdotes to talk through on your data lake strategy and where you're going with a data lake. So without further ado, let's start. So a common myth when it comes to data lakes is once we have decided to start on that journey towards a data lake, that actually the data lake is the strategy, and that's a common myth. Is the fact that you've decided to have a data lake means that you now have a fantastic AI/data/analytics strategy, and unfortunately that's not the case. What we tend to find with data lakes is that data lakes form an essential part of a strategy, but they are by no means the strategy in themselves. And so when we talk about a data lake as part of a strategy, what we're actually talking about is the ability to consume data in what can tend to be called an inflow data lake. So where data is flowing in from all parts of the organization into one consistent platform, so that you have the single view of various data items within your organization. So the data lake is my strategy is a myth that is built up over time. One of the things that trip up a lot of organizations is the ability to have a consistent approach to data management. So the ability to have a team that's able to do all of the critical data management functions, ranging from everything from data quality to data ingestion to data distribution. And they think that standing up a data lake solves all of the ills of data management. In fact, a data lake brings data management into focus, and that we need to start thinking about data governance, data quality, and understanding the content that's within a data lake. So as you can see, once you start thinking about the fact that I now have a data lake, that it is just a critical part or a component of a data strategy. And then there tends to be a lot of what we like to call capability mismatch. Is traditionally when it comes to data warehousing, building data marts, we've tended to live in a very much an insular data-driven tooling paradigm, where we've spent quite a lot of time and effort and money on extract, transform, and load tools, or the classic ETL tool. And we think that's the core capability. Within a data lake, we've actually moved on and focused very much on what is now known as data engineering. So the ability to bring good software engineering practice into the realm of data engineering and then into extract, transform, and load. And that commonly trips up a lot of data lake initiatives. Is there's very little focus on building that core software engineering capability out that enables you to get the most value out of your data lake. So once you've built your multi-node cluster, whether you're looking at some sort of Hadoop/Spark, or you've gone to a cloud native approach where you're using things like S3, Glacier, EMR, Redshift as part of your data lake strategy, without having that core fundamental data engineering capability, people tend to trip up. They think that part of the data lake strategy is actually building the cluster. In fact, building the cluster is just the first step. There is a lot of work that goes into understanding what are we going to be feeding into the data lake. What are the use cases that we're trying to light up as part of our data lake strategy. And then finally, when it comes to data lake is my strategy, we look at things like metrics, accountability, and roles. But we need to start focusing on what are the type of roles we need to make this data lake successful. And it's not just purely the data engineering capability, but it's also the project management, the service management, the ability to, once the data lake becomes a critical part of your IT strategy, is can we manage it, can we maintain it, can we keep pace with the growth, the demand, and can we create a core set of metrics that actually show that the data lake is starting to consistently deliver on the promise, which is if we can put all our data into one place, can we actually start to derive some great value from it? And no strategy is worth its salt unless you've started to understand the political and the cultural aspects that building a single version of the data within an organization, building the capability to inflow data and outflow data to downstream processes and start to curate and manage the content is how you're going to change the culture of an organization, how you're actually going to make this a fundamental part of the way in which you operate. So just the mere fact of having a data lake is not a key component of your strategy. You need to actually have the whole roadmap. You need to bring the organization along, and just the mere fact that you're going to have one, I hope you're starting to get the gist of this point, is that you don't actually have a strategy until you wrap the data lake in all of the components that you'd expect. So let's move on to the next slide. One of the actual facts, and it's not so much a myth, it's an actual fact, is that the data lake can erode and degrade very, very fast. And one of the issues that you have is in the old world of data warehousing, the mere fact that we'd spend an inordinate amount of time focusing on the design of the enterprise data model, we would spend a lot of time thinking about the logical data model and down to the physical data model, and the sheer effort that that took meant that we were able to curate and be custodians of the data that flowed in to our data warehouse. Within the data lake paradigm, the fact that we've moved very quickly onto schema on read means that data lakes can very rapidly become the dumping ground of all things data, and people will tend to use it more as a file repository rather than an analytical data resource that can be used to create some insight within your organization. So what we end up doing is ending up with a data skip or a data pool or a data swamp, you name your favorite data lake analogy, that's what you end up with as people start to dump data from various sources, streaming data in from Kafka, putting it into some horrible XML file format, spending a lot of time creating Avro schemas and then letting them degrade over time, not utilizing capabilities like schema registries to understand how the schemas will evolve over time, ends up creating this data lake that has degraded fast. And so when we look at data lakes, what we are increasingly seeing is our clients evolve towards governance and understanding this concept that we like to talk about in terms of content registration, is you can't just push data into the data lake unless you've actually registered the content. And there's been vast fortunes made and companies created on their ability to register content and then assign a value to it, and then in order to create what is commonly a billing engine and charge people per row or per column. And if an organization starts to think in those terms, that actually if we can register the content, if we can keep this content well curated, that we can increase the hygiene around the data, that it starts to have some inherent value. At that point, this content registration engine that sits within the data lake means that the data lake won't degrade, because at that point people understand that the data has some inherent value, and that actually just writing data at will into the data lake and allowing it to degrade over time serves no value. And so there's very much this focus when you look at a data lake and prevent the degradation, is to be able to A, register content going in, and B, assign a value to the data on the way out, And that way, people and organizations start to see the value and actually start to treat the data as an actual asset. So I think there we've pushed how and the importance of a data lake and keeping it well curated is increasingly important. So moving on to the next slide, we have yet to write down our experiences. And I think that's an interesting slide to have and somewhere for us to dwell for a couple of minutes is data lakes being fairly new, relatively speaking to other forms of data warehousing, data marts, is we've yet to create the myths and the legends. What we need to start doing as a practice and as a capability is to share as a community what the experiences that we've had around data lakes, around what works, what doesn't work, and this whole idea of writing down the experiences. So I thought it would be good at this juncture just to share a couple of my experiences in building data lakes, and some of my experiences is, number one, it's about this semantic understanding. We failed building out traction because we were unable to semantically describe what was in the data lake. Back to my previous point about content registration, without a consistent catalog and a consistent registry and understanding of what's in the data lake, if people don't know what's in it, they won't come and use it. So this whole idea of having a semantic understanding is critically important. The other area, and we've been talking about this for years and years and years, is around data governance, is the ability to govern and control the data. In any data repository that we've had has always been critical, but probably a lot of lip service paid to governance. Data lakes within themselves are critical that you have a great governance function, especially when the data contained within is starting to be used to support machine learning and deep learning, where people need to understand what was used in order to generate the insight within the data lake. Without that governance in place, means that we cannot rely upon the decisions that have been made and the decisions that have been supported based on the data that's been within the data lake. So it's critical that governance plays an increasingly central role within the adoption of enterprise data lakes. And another element is performance. And this is an interesting point when it comes to performance, because as we've moved to a more NoSQL driven world, the programmer / engineer becomes the query optimizer. And so their focus has been on driving performance, whereas in our more relational world, performance has been predicated on 20, 30 years worth of query optimizer. And so if you can't create an extremely performant data lake based on both the ingest and egress of data, your data lake strategy will not deliver as much as you'd hope, because performance unfortunately comes at the cost of users not wanting to utilize your data lake if they're not getting the sort of performance that they'd be looking at. And so we've spent an inordinate amount of time when we build data lakes focusing on performance tuning, on tuning clusters, given the fact that we start to work in a very JVM-oriented world, is that we spend a lot of time JVM tuning, tuning storage layers, looking at the different capabilities and the different architectures that have now decoupled the data lake storage from the data lake compute. So performance becomes an increasingly big factor. And it's part of the experience that we start to talk about is that performance will either make a data lake very successful or it will kill a data lake. I'm going to move on to the next slide. So this is more for how you go around delivering the data lake. And I think a lot of data lake projects have failed because they've tried to take on too much all in the same time frame and gone for the big bang approach. that they've decided that they've received the budget and the sign-off, and now it's time to get cracking, and they're going to try and ingest every piece of data that's available within an organization. And they've set a huge strategy in play. Some of the clients that I've had to go in and rescue data lake projects is where, when you calculate the number of data sources that were available to ingest into the data lake and the speed at which they've been doing the ingestion, you're looking at 5 to 6 years before they've gone around every source system and fed it in, without a focus on what is the actions that we want to derive from this data that we're feeding in, and what is the value that's going to come from it. So when you look at a data lake strategy, it is about where is the value, where are we going to get the biggest bang for our buck, where is a data set or a core set of data that we can feed into the data lake and ultimately extract some value from. And this is a critical point, is start small. Just because it's called the data lake doesn't mean you have to fill it from day one. And if you take small, incremental, value-driven approach, it means that you can start to slowly but surely create a groundswell of support and activity. And what that will enable you to do is then get some traction, and people can start to see the value that the data lake can bring. So start off small, focus is very critical. And also the big issue that kills data lakes is cost. Is as we start to take on more and more data, and as we start to generate more and more insight from the data lake, the cost obviously increases. That's both the cost of resources to actually drive the data engineering and the data science functions, as well as the cost of storage and the cost of compute. And given the fact that we spend a lot of time now building cloud-oriented data lakes, is we've moved very much away from a capital-intensive world into an OpEx world, and there needs to be a governance model that sits in place that governs the amount of resource, which is directly proportional to the cost, that we're willing to spend on a monthly basis to derive the insight from the data lake. So there's no escaping cost element when it comes to building a data lake. And so once you start biting off those small bite-sized chunks and you start to deliver some value from the data lake, you'll increasingly get more people joining the process and are willing to actually spend the money because they're starting to see some real value from the data lake. So the essence of starting small is literally to drive that groundswell and avoid the big bang approach, because a big bang approach, as we know, fails terribly. I think we're at this juncture in technology where most data lakes are built in the cloud, and most organizations that have a cloud-based data lake have a cloud-first strategy, which means that you can start off small and build and build and build. Gone are the days where you have to go to the CFO of your organization and ask for a rather large check so that you can wheel in a large amount of hardware and software to affect your data lake strategy. I tell quite a few of my clients it's a great point in the data lake lifecycle when you get to that point where the economics to start thinking about bringing it onto an on-prem footing means that you are A, deriving a lot of value, and B, you've reached that tipping point where it may make sense to manage the infrastructure and the whole process in an on-prem setting. And I think that is a mark of whether your data lake strategy has been successful, is if you're starting to hit those types of conversations. But in the interim, starting small, cloud-based, looking at the different storage options, looking at the different compute options, the ability to spawn and contract and derive that elasticity is only available within the cloud paradigm. So here's a area that you need to start thinking of, is that the data lake in itself is data infrastructure. And a lot of organizations historically, when you look at a data warehouse and a business intelligence stack, was very much a solution and wasn't part of what we traditionally think of as infrastructure. But now we've reached that point within technology that you can actually assign the data lake as data infrastructure, just as you would networking, just as you would servers, just as you would the cloud. See it as an infrastructure service play. And so as a result of focusing on the data as infrastructure means that it is there, that there is a set of non-functional requirements around performance, around availability, around disaster recovery, all of those elements that have previously been very much the purview of technical architecture and infrastructure. Now we can assign that same concepts to data as infrastructure. So that irrespective of what you're doing from an application development perspective, what you're doing from a consumer mobile voice perspective, everything generates data. And so if you start thinking that actually the infrastructure that you use is data infrastructure, means that you can start to inflow the data into this infrastructure and egress and derive a large amount of value, rather than thinking of the data lake as a solution as a whole. Start to think of it as a evolution of infrastructure. And so it may be a useful strategy and lever within your organization to start to think of data as infrastructure. And by doing that, you are able to drive people towards the infrastructure. I'm now going to move on. And I think I touched on it early, is it's time to take a new look at data management capabilities. And what I mean by taking a look at data management capabilities, it's the how do we get the data in, and how do we transform it, and how do we get the data out of the data lake. And so traditionally, when we were looking at ETL tools, we spent an inordinate amount of time thinking about schemas, thinking about structures, how we're going to hold the data, what are the type of workloads. So now when we look at data management capabilities, I like to think of them in a couple of broad terms. You will always have a requirement for data management capabilities around relational data management. So the ability to take very structured data, your traditional rows and columns, and transform them, join them, and push them down into a structure that can support analytical querying, reporting, be it regulatory reporting, be it transactional reporting, be it business intelligence. You're also starting to see a huge emergence of the ability to apply graph-oriented workloads. And when it comes to graph-oriented workloads within the data lake, it's a different type of schema. It's a different type of data management capability that you need to transform the data into nodes and edges. And so it's an area that when you traditionally looked at your data management capabilities, you may not have had graph in mind, but now increasingly a lot of business problems that you're trying to solve with the data lake drive you towards a graph-oriented workload. So it's a good idea to start thinking about how am I going to bring more graph data management capabilities within the team. The third area that we like to think of when it comes to data management capabilities is the ability to bring feature engineering, and it's being able to derive a huge amount of features from the inbound data that can then be transformed, either pre-calculated and stored or calculated on the fly. And these features then are served up to machine learning models, both in terms of training the machine learning models as well as serving up the features when you're in model evaluation mode. Those data management capabilities that enable feature engineering do a couple of great things. One is provide a consistent set of features that can be drawn on by the machine learning data science community. as well as reducing a lot of the load on the data science community so that they don't have to spend as much time in the data management realm, and they can spend a lot more time being creative and expressive when it comes to machine learning. And then when it comes to deriving the machine learning evaluation in production, the data engineering team has had more say in how these features are transformed and served, meaning that you reduce the cycle time from hypothesis to decision, which increasingly is important as a lot of data science and machine learning projects start to leave the proof of concept, proof of value arena and find their way more into line of business production workloads, knowing that these can be done in a very resilient and consistent way. So looking at the data lake does give us that opportunity to go and have a rethink about the types of data management capabilities that we want to stand up. And given the fact that we're looking at a structured world, we're increasingly looking at graph workloads, we're increasingly looking at feature engineering, and streaming means that we need to be on our game when it comes to both the management and the governance of the data flowing through, because in a regulated industry such as financial services and pharma, your regulators will want the full lineage, the full end-to-end traceability from source to target, and that sits firmly in the purview of data management capabilities. And finally, in the couple of minutes we have remaining, is, and I've touched on it throughout, is to focus on the value. There's no point building a data lake without any value. And so let's just touch on the types of value that you can start to consider when thinking about how do I position my data lake. So first and foremost is the information value. So how am I going to increase the value of the information that I derive from the data that flows into the data lake? How am I going to improve the value that we get from the data that we generate as a business? How do I start to add external and alternative data sources to the data in order to enrich it and to provide more value? That is critical, and you have to put a value on the information value. Is a lot of information value is tied to a time series. So you tend to see that within the first couple of seconds, the information has a large amount of value. And as that time series expands, the value decreases, and then slowly but surely it increases again as more history is generated. And a lot of business insight is driven from the ability to compare trends and to look over history. And machine learning is all derived from the value of being able to learn from a huge amount of data, which only comes from managing and curating it over time. The second type of value that we look at when we look at a data lake is the business value. What business processes improve with the use of the data coming out of the data lake? How do we add more value to the business transaction? How does this value relate to improving customer experience? How do customers are better served? How do we understand their needs and wants? How can we use the data to our advantage to drive more business, to improve competitiveness where we are operating in a highly competitive marketplace? How do we comply better when we work in a highly compliance-driven, regulated environment? And finally, how do we drive cost out of the business by being able to use that insight that gets generated? And finally, we start to think about stakeholder value. What does the data and the analytics that we can do on top of this data lake, how does it derive value? So there's various avenues to derive value. The holy grail of most organizations is to take the data that they generate as a business and start to monetize it. Can they create adjacent business models by selling or utilizing that data across their partner ecosystem? we start to think about how the consumers can benchmark their cost, the value that they derive from your business against other avenues where they conduct business as well. So this whole stakeholder value becomes increasingly important. So hopefully in the last 30 minutes, I have had a few people say that they have no sound, but I have been told by BrightTALK that the sound is working. So unfortunately for those, there could be something wrong with your systems. At this point, I'm more than happy to take a few questions from the audience. I do have a few questions that have come up in the interim. Is how do we avoid failure? And I think when it comes to avoiding failure of the data lake project, some of the recommendations that I have around avoiding failure is understand the data, understand the life cycle, how you manage the data, your ability to actually communicate with stakeholders, that you can actually tell them about the lineage, that you can understand what failed, what the failure and the impact of a load or a failure of the data and the timeliness and the accuracy of the data means to them. So the ability to have a rigorous policy around how you manage the whole data lifecycle. The other area is around quality, is your ability to clearly communicate what is quality data. When you reject data, I had touched on earlier around that whole concept of data registration or content registration before it enters the data lake. At that point, you set SLAs and tolerances around the data that's feeding in, so that the stakeholders are well versed in what their expectations are in using the data lake. Another question that I've got is, we have a lot of SQL-orientated data ETL engineers. What is the requirement for them to become more productive in a data lake environment? That's a great question. That's a question that I get quite often. When I look at that, is the ability to train them in software development and software engineering disciplines. A lot of SQL-orientated data engineers have spent a lot of time working in SQL. They've spent a lot of time working in tooling, your traditional ETL tools, Informatica, Ab initio, DataStage, those kind of tool environments. And now they find themselves in a data lake environment where you have to be very conversant in functional programming, using things like Scala, Java, and I do advocate the ability to totally immerse them in object-oriented programming and get them very rapidly up the maturity curve in terms of good software development capabilities. And I think that is why we've also seen a huge push in the data lake technology sphere to retrofit SQL-orientated endpoints over traditional data lake technology. And that's why we've seen the advent of things like Hive and Impala and Spark SQL and all of those sort of interfaces, because of the learning curve and the bar that needs to be overcome in order to be able to become productive as a practitioner within the data lake environment. I'm not getting any more questions coming through from the audience. So at this point, I will thank you all for your attention, and I hope you got something out of this presentation. And feel free to contact me. My contact details are there, gary.richardson@6.6.co.uk. We are a digital transformation consultancy based in London, and I would welcome a conversation. Hope you had got some value out of my presentation, and with that, I thank you very much, and I will sign off.